So, welcome you all for another presentation on control system subject. Today, I would like to explain you about the concept of stability using frequency response. Right? The concept of stability using frequency response. Basically, we have various methods for finding the stability of any given control system using this frequency response. There are various methods. So I will explain you what are the methods. If you see, the first method is it is a polar plot. The first method is polar plot. This is one method of finding the stability of the system using this frequency response. And the second one is Nyquist plot. The second one is Nyquist plot. And then the third one is Bode plot. Okay, Bode plot. So these are the various important methods that are being used for finding the stability of any given control system. These are called the various methods will be used in frequency response for finding the stability of the given system, right? In fact, what is the stability? Why the stability is required? Stability is nothing but how stable the given system is, we have to estimate, right? So in simple, remember that for any bounded input, the system should produce the bounded output. Bounded is nothing but the limited. Here, bounded is nothing but limited. It is meaning nothing but limited, or otherwise also called as controlled. Okay, the meaning of bounded is nothing but controlled, limited, or the controlled, or it is definite, or otherwise it is definite. Definite is nothing but the value must be known, the value must be certain, the value must be limited. For every limited input or for every known input, for every defined input, the system should produce the defined output. In simple, it is called as for every bounded input, the system should produce bounded output. That is why it is called BIBO stable. Bounded input, bounded output, stable system in general, right? And in detail, we will see in the subsequent presentations regarding this stability. And in this presentation, I would like to explain about the first one, the polar plot. What is a polar plot? Which is the basic method, basic method of finding the stability using the frequency response. Remember that if you recall our feedback concepts that are being used in control system, for any control system, let us say with a negative feedback system, the basic block diagram of feedback control system gives rise like this. I think you are already aware of this. Just for our quick reference, I want to refresh you once again, right? So this is the basic simple block diagram. This is our R of S input. This is our output C of S. This is the gain of the amplifier, and H of S is the gain of the feedback element. So it is always, the input is always plus and the feedback is given with negative feedback. Therefore, for this negative feedback, what is the transfer function? What is the transfer function? Transfer function is nothing but it is the ratio of C of S by R of S is equal to, what is the formula? It is G of S by 1 plus G of S into H of S. Remember that. This is the formula that we should remember for negative feedback control system. for transfer function, right? So for any given problem, it will be given that the transfer function will be given. So in the frequency, now we are going to study about the frequency response. We are going to study the frequency response. So for finding the frequency response, we need to know, or we need to find out the transfer function of the given system. We must know, or the transfer function must be given for the given system, so that the frequency response of the system can be easily determined, or easily calculated, or easily estimated. Clear? Okay, let us, for our convenience, let us consider this particular transfer function. So, okay, we know the transfer function. Now what we should do, what we will do? Okay, so we know that the transfer function of a negative feedback control system is given by, transfer function is equal to, it is the ratio of output C of S by input R of S is equal to, it is simply G of S by 1 plus G of S into H of S. Clear? Now, now we have to apply the S value wherever S is there. The transfer function in general, that is in terms of, it will be given in terms of S. So substitute that S is equal to J omega. Remember that. Substitute S is equal to J omega in the given transfer function, right? So that means that it is C of J omega by R of J omega, clear, is equal to, what is this? G of J omega by 1 plus G of J omega into H of J omega. Normally, in the given transfer function, we have to substitute S equal to J omega. Here, for finding the frequency response, the response will be plotted in S domain. The response will be plotted. Response is nothing but it is a graph actually. That is the graph which is plotted on S plane or the S plane. So how it looks like, let us see. So before going to explain little bit information about this transfer function, I will explain you what is the S plane. What is S plane? S plane is nothing but it is the graph. It is the graph actually, or it is the graph consists of x-axis as well as y-axis. Is it not? X-axis and y-axis. X-axis is nothing but it is the real part. It consists of the real axis or real part. Okay, and similarly on y-axis we will take the imaginary, or it is called the imaginary axis. It is called the imaginary axis, or otherwise also called as J omega axis. This is J omega axis. Y-axis is nothing but J omega axis, and x-axis is nothing but the real axis. Is it not? Means that for any given transfer function, you have to identify the characteristic equation of the transfer function. The characteristic equation. What is the characteristic equation? That is simply called as CH equation, or otherwise it is characteristic. It is the characteristic equation. What is the characteristic equation? It is nothing but, this is nothing but 1 plus G of S into H of S equal to 0, right? 1 plus G of S into H of S equal to 0. This is nothing but the denominator part of the transfer function, right? So if you equate the denominator part of the transfer function of the negative feedback or positive feedback, whatever it is, if you equate to 0, that is called as equation, and this equation is called as the characteristic equation. And from this equation we have to find out the roots of characteristic equation, or in simple I can write CH equation or characteristic equation. So from this equation we need to find out what are the roots, and those roots will be marked on this S plane. And sometimes the roots contains real number, real plus imaginary number, it is some complex conjugate. In many form it will be, the roots will be, okay, the characteristic equation contains different roots, maybe sometimes real roots, or sometimes real plus imaginary roots, or sometimes the imaginary roots alone, like that. So for any given transfer function we have to take the characteristic equation, and from the characteristic equation we have to find out the roots, and those roots are nothing but are called as the poles of the transfer function. Very important. The roots of the characteristic equation of the given transfer function are called as the poles of the transfer function. Now these poles will be represented on this S plane. So these poles, as I told just now, explained just now, the poles will be most of the time maybe real, maybe combination of real plus imaginary, or imaginary alone, no problem. So these poles will be identified or marked or represented on this S plane. S plane consists of, this is called S plane actually in general. So S plane is nothing but this is the graph actually, it has x axis and then y axis. Okay, now okay, this is the S plane actually. Okay, so here the angular frequency is the, as we are applying S is equal to j omega, as we are applying S is equal to j omega in the frequency response. Now our aim is to find out what is the values of this angular frequency, how the angular frequency will varies from where to where. That is very important question. Remember that in polar plot, because now we are concentrating on this polar plot. In polar plot the angular frequency omega varies from 0 to infinite. Remember that. So the angular frequency omega varies from 0 to infinite. Okay, so in the given transfer function, we have to substitute the omega value 0 first and find out what is the magnitude and what is the phase angle of the transfer function at omega is equal to 0. And similarly we have to substitute the omega value infinite, means that what are the values of the magnitude and phase angles of the transfer function at omega is equal to infinite. Means that omega has two values, that is one is 0 and second is the infinite. So we have to find out the magnitude and phase angle of the given transfer function at these two values of omega, and from that we have to plot the graph. Clear? That means that let us say, for example, I will explain you a small example based on this so that you will understand better. Right? Let us consider a simple example. Let us consider g of s is equal to 1 by s. Let us say this is the transfer function. This is very simple example I am explaining you to make you to understand more better about this concept, right? So a simple transfer function I have considered, that is g of s, which is nothing but the transfer function, that is 1 by s. Now for this transfer function, first of all we have to find out what is its magnitude, what is its phase angle. For finding the magnitude, remember that we have to find out the magnitude first, what is the magnitude, and second is the phase angle. What is the second one? Is the phase angle, right? So what is the magnitude and what is the phase angle? These two are the important parameters that we need to find out. So for that, for finding this, what we have to do, substitute s is equal to j omega. Substitute s is equal to j omega in the given transfer function. So by substituting that, what you will get, g of j omega is equal to, it is 1 by j omega. Am I correct? Then what is the magnitude of this? Magnitude is nothing but that is represented by modulus g of j omega. Clear? What is the magnitude? So magnitude will be defined or identified by this modulus of j omega is equal to magnitude of 1 by j omega. Is it not? We have to consider the magnitude. This is nothing but, what is the magnitude? It is nothing but, actually, if you see this 1 by j omega can be written as, actually it is 1 by real part plus j omega. Is it not? What is j omega? It is the imaginary part. So in this there is no real part. So any number can be denoted as the sum of real part plus imaginary part. Any complex number, a plus ib form or x plus iy form. X plus iy. X is the real, iy. Y is the imaginary. Therefore, here 1 by j omega is nothing but, it is imaginary, nothing but plus 0. Real is not given. Therefore, consider as 0. Therefore, it is 0 plus j omega actually. It is 0 plus j omega, really speaking. Then if you take the magnitude, that is nothing but 1 by square root of real part square plus imaginary constant. What is the imaginary coefficient? Omega. So real part coefficient, square of the real part coefficient plus the square of the imaginary parts coefficient. What is the imaginary part coefficient? Omega, means that omega square. Therefore, this is nothing but 1 by square root of omega square. Therefore, the square root and the square will cancel out. You will get 1 by omega. That is what your magnitude. So, magnitude of g of j omega is equal to 1 by omega. This is the magnitude. This is the magnitude. And then what is the phase angle? Phase angle of j omega. What is the phase angle? So phase angle is nothing but, so that is denoted by phase angle. Remember this. This will be written as like this. This is what. If you write like this, angle of j omega, that is nothing but tan inverse of. It is actually, if you see the denominator part, it is a constant actually. It is a constant actually. Is it not? It is a constant. Therefore, nothing is there. Nothing is there. Okay. Therefore, only we have S part 1 by, what you will write actually? It is the tan inverse of. What is the imaginary part by real part? 1 omega by 0. Okay. So, here, if it is 1 by j omega, you simply consider the denominator part, that is nothing but 0 plus j omega. For this, the angle will be written as tan inverse of 1 by tan inverse of imaginary value, imaginary coefficient by real coefficient, omega by 0. Is it not? This is nothing but 1 by tan inverse of omega by 0. Okay, something by 0. How much? It is infinite. It is infinite. When this will becomes infinite, so tan inverse of infinity is nothing but, it is how much? It is pi by 2. It is pi by, or otherwise you can write so it is tan inverse of infinite, or if you can take to the numerator part, it is minus tan inverse of infinity. You can write like this. So 1 by tan inverse of infinite, if you take this in the numerator, that is minus tan inverse of infinity. That is what your phase angle. That's it. Your job is over. Therefore, in general, what we can say, in general or in simple, we can write that the collective answer as, so for the given problem, the magnitude of g of j omega and angle of g of j omega, you can write in any way, no problem. This is equal to, what is the magnitude actually? It is 1 by omega. What is the phase angle? It is 1 by, you can write like this, no problem. It is minus tan inverse of infinite. Tan inverse of infinite. That's it. This is the solution part of it. Then afterwards, you can simplify in the polar plot. You apply different values. What are the values actually? Your omega varies from 0 to infinity. As your omega varies from 0 to infinity. Is it not? Is it not? So, if you substitute omega is equal to 0, so at omega is equal to 0, what is the magnitude? What is the phase angle? So, if you substitute omega equal to 0, what will be the, it is 1 by 0. 1 by 0 is how much? Something by 0, it is infinite. Okay, is it not? If you substitute omega place in omega place, if you substitute 0, 1 by 0 is infinite. So magnitude is infinite. And then what is the infinity? It is angle is all minus itself. Tan inverse of 0. What is the tan inverse of 0? When it will be 0? It is 0 only, no? So it is 0. It is 0. Okay, and similarly at omega is equal to infinite. Now substitute at omega is equal to infinite value. So substitute omega is equal to infinite. So at omega is equal to infinity. So substitute 1 by infinity. 1 by infinity is, it is 0. 1 by infinity is 0. 1 by infinity is 0. Therefore, what is the phase angle? When your infinity, when it will become, when tan inverse of infinity is nothing but what is the phase angle? It is pi by 2. It is pi by 2. It is minus pi by 2. It is minus is there, it is pi by 2. Therefore, now these are the values of magnitude and phase angles for different values of angular frequency 0 to omega. Therefore, if you substitute, if you represent these values on that graph, then your graph will be looks like this. How your polar plot will looks like? It is nothing but something. It is again graph is like this only. Your graph is something like this. Okay. So it is actually 0. It is 0 degrees, and then it is 0. This is minus 90 actually. Likewise, you have to consider. Likewise, we have to consider. Is it not? So it is 0 degrees actually. Start from, or otherwise no problem. Or this is 0. We have to consider like that only. This is 0 minus 90, because in this we have to consider in this way, anti-clockwise direction, the angle. The representation of angle will be considered like this only. 0, it is minus 90. This is minus 180. This is minus 270. This is minus, this is either 360 or 0 like that. Therefore, how at omega is equal to 0, what is your magnitude? Infinity. So means that what? At 0 angle is this only actually. Remember that. This is 0 or 360. Carefully see this graph. This is 0 or 360. Again come to this side. This is minus 90, minus 180, minus 270, again 360. So clearly observe here. At omega is equal to 0, what is the magnitude? Infinite. What is the phase angle? 0. Means phase angle is 0 only. At 0, your magnitude is coming somewhere. We don't know. It is infinite. Your magnitude is coming from infinite point. It is coming from infinite. Okay? It is coming from infinite, reaching to 0 value at minus pi by 2. Means that, so at 0, the magnitude is coming like this. Somewhere it is coming like that. Arrow mark you represent in this way, upward direction, because from infinity it is coming. We don't know, that is from infinite point. Therefore, we have to represent like this, and it is reaching to 0. It started at infinite, reaching to 0. 0 is nothing but again 0 value this only. At minus pi by 2 means minus 90. This is minus pi by 2 actually. means that this point means this graph is reaching to 0 like this. This is the end point. This is the polar plot. So the magnitude is coming like this, from infinite it is coming, means that it is omega is equal to 0 actually. Omega is equal to 0, basically here omega is equal to infinite. Here omega is equal to infinite, or what is the magnitude? Magnitude is equal to infinite, or otherwise this is omega is equal to 0. What is the magnitude? Magnitude value is infinite. Here it is magnitude 0. This is what the polar plot. Clear? So I think we will finish off here, and we'll continue the rest part of the continuation part of it in the next presentation. Right? I hope you understood well, and see you.